Alright, so now we start the programming part. Remember we have the schematic set up with our data bus going to port C, and then port A running all our other functions, our chip enable, our reset, and then which digit we want to send the data to. And we're not going to first. Basically, I'm kind of doing this on the fly, so I can show all the errors I run into, and then I'll try to correct it as I figure them out. So we're going to set up the basic define statements here in the program, and define our ports and define our pins like we have set up here. And if you remember from newbiehack.com's tutorials, basically we set up these define statements so that it allows us to switch ports easily without having to rewrite a bunch of all the program we have set out. Say we have everything wired up to port C, and then there's some kind of problem, we want to try another port, maybe we want to try a port over here, port D. And if we set up a define statement, then all we have to do is change like one word and set our what we have set up for the database port. We just change it from port C, say, to port D, and rewire up the chip and flash the chip, and we can try that different port. We can move pins around or whatever. So start off with first of the define statements. Basically, I'm going to call the data bus osram data bus, and we're setting that equal to port C. So like I said, because we've named whatever port our data bus is going to be, we've defined it with this name, osram data os data bus. Then if we need to swap over our port C, say for some reason we want to change it to port D, all we got to do is erase the port C and put in port D and reflash the chip, and we're good to go. And then we'll define our other other port, which basically is going to be running the chip enable, the reset, the A0 through A2 to address the digit, and I think that's about it. I'm just going to call it, you can call it whatever you want. I'm going to call it osram auxiliary, and we're using port A for that. So alright, now we got to define our pins. We basically have to define the data bus. We don't really have to define these pins because we're going to send a whole byte over at one shot, and basically we're just going to send the whole byte to port C. But we do have to define the pins on port A, each of these pins separately. We'll be sending a different ones and zeros to it, depending on whether what digit we're writing to, and also a write cycle. So I'll define the reset pin first. And I'll call it osram reset. In this case, our reset, if we follow along, our reset is set up to port A, pin 0. So set it to pin 0. We'll set it to 0. Next pin we'll define will be a chip enable 1. And look over here, chip enable 1, following along, goes to pin 1. Next pin, CE0, chip enable 0. Chip enable 0 is pin 2. And the next pin is A2. Follow A2 along. Pin 3. And A1. Pin 4. A0. A0 to pin 5. Last but not least, OS, our right pin, which is pin 7. I tend to want to keep everything in a line, a column, to make it easier to read. We have enough problems, I have enough problems with confusion without adding to it. Okay, to find our pins, like I said, we're trying to leave these other pins. I'm not even going to hook up the read to 5 volts initially. I'm just going to try to leave these floating, not connected, and see if it'll work. And then if it doesn't, then I'll hook them up. And okay, next thing is going to we're going to make our first function. Basically, we're going to try and write to the first digit on the osram display, digit 0. So I put include statements up here, the usual AVRIO, and we're using utility delay because it needs to be a certain, we need to add a little delay when we write to the chip, to the osram chip, because the microcontroller moves so fast. Got to slow it down a little bit, so the osram has time to read the incoming data. So we'll set up our first method here. There's going to be no return, and I'll call it write to digit 0. And our input, or input variable. I'm going to try unsigned character, my character, and basically that's this is where we're gonna put our byte and send our byte with our ASCII data. Remember from our data sheet here, if you look at it, it gives you a table here with all your characters you can display on the display, your ASCII code, and basically that's your ASCII code. That's that byte you're going to send over the data bus. Tell the Osram display what number or what letter or what symbol you want it to show on the display, and that's what's going to go in here as a character, a byte. And then in this function we're going to set up the chip enables and tell it what address. Obviously this is going to be the 0, the first digit, the 0 address, the 0 digit in the Osram display. And they give you a little table for right here. See, for digit 0 you have to have A2 set to 1 high bit, and then A1 and A0 set to 0. So we're also going to do that in this function because we want to send our byte to the first digit, and we have to enable the chip. Excuse me. And then after that we have to tell it to write. We have to send a high bit to the write pin. Start it low, bring it high, bring it back low, and that'll shoot our byte, our ASCII byte, over to the display and hopefully display it. Alright, so first we'll tell what address we want to send it to, what digit we want to send it to, because it's right to digit 0. So the first statement, we want to take our we want to write to port A, and we want to write to pin A0, and we want to set it to 0. Then we want to set the A1, we want to set it to 0 as well. So I'm lazy, I do a lot of copy and pasting, I hate to type. And then our A2 we want to set to a high bit. Let's copy this whole thing. And if you remember from newbiehack.com, we set with hash mark equal sign to set the our A2 bit needs to go high,